Everybody, today we are going to do a lab on mass versus weight for Newton's second law. To get started here, what I'd like you to do is I'd like you to open up your lab notebook and create an entry for mass versus weight. Make sure to include it in your table of contents and create a heading and date it, a new entry for a mass versus weight Newton's second law lab. Once you've done that, you can copy the purpose down that you see here on the screen into your lab notebook. For this particular lab, you are going to enter in some information that I provide to you and then answer some questions at the end. This is not a formal lab report, which is going to contain an analysis section and some other information that we usually enter. So in this lab, what we are going to be doing is we're going to be taking various masses. This is a mass set, and we are going to be taking various masses, and we are going to be using the Pasco force sensors to measure the amount of force that these masses have when gravity is pulling them down. Before this lab started, I used this balance to verify that the masses here were the correct value. So this is a 200 gram mass. On my balance, it measures 200 grams. For the data collection section, we again are going to use the Pasco force sensor. So I'm going to start up the force sensor, and when I start this up, I am going to make sure that I have the correct channel. You can see if I pull down on this little hook, we get additional weight. Down is negative, up would be positive. These things max out at 50 newtons, so we have to be very cautious. We never put them over 50 newtons. We're going to tare this or zero it to start. I'm also going to take it out an extra decimal spot. Note that the precision of these instruments is only to about 1/10 of a newton precisely. We can take it out a little bit further, but what I do find error starts to creep into our experiments. With that said, that is still pretty precise for an instrument, a classroom instrument like this. A lot of times we use just spring scales, and we're measuring to the half a newton. We're going to be able to measure this down to 1/10 of a newton, which is a good thing. So what we're going to do is we're going to hang various masses on our spring, on our force sensor, and I'm hanging here a 1 kilogram mass. You see this is bouncing around a little bit. Some of it has to do with me moving up and down. We'll talk about how that happens, but holding this very steady, we can see that we get about 9.8 negative. So I'm going to put that in here, negative 9.8 for the weight. The next thing I'm going to do is I'm going to try the 500 gram, the half a kilogram mass. I put that on here. Negative 4.9. And we're going to round this to the 10th. Even though it's bouncing out a little bit further, we are going to round this to the 10th. As this is happening, we can see over here on the side, we are getting a graph. That graph has some data points on it, and as we're going to see, it's going to give us some information, including the slope. It looks like I put negative 9.6. I want to put negative 9.8 here, which is our value. The next one I want to put on is the 200 gram, 0.2 kilogram. Take this mass, I hang it on here. Looks like negative, it's bouncing back and forth between negative 1.9. Looks like it's hanging out around negative 1.9 most frequently. Okay, and then we're going to do the 100 gram mass. I'm going to tare this again just in case. I saw it jumping there a little bit. Stop moving, we'll tare it. There we go. I put the 100 gram mass on there. Negative 0.98. We're sticking with that 2 significant figure value, negative 0.098. Negative 0.98. There we go. And then the last value is going to be 50 gram very small mass here. I'm going to hang that on there. Negative 0.51. And so we now have a graph that represents the ratio between the weight and the mass. And we also have a graph here that represents the overall data. I'm going to give you this to put into your lab notebook. I'll take a picture of this and post this with this document, so that way you have this. You will want to put this into your lab notebook. There's some interesting things that you should look at when it comes to the graph itself. When I take a look at the graph here, I have a nice linear line. Think about what this graph is showing. We have a y value of weight. We have a x value of mass. The slope would be the other variable. And in our equation, F equals ma, force is equal to mass times acceleration. Force is in the y position. Mass is in the x position, and the slope of that would be the acceleration due to gravity. And when we take a look here, we are seeing the acceleration due to gravity. Now, this is an alternative way of validating that. So write it down, y equals mx plus b, and you can validate that value. What I'd like you to do after you enter this into your lab notebook is answer these questions. I'm going to turn off the sensor here. There are some questions. You can stop this video and answer these 4 questions in your lab notebook underneath the graph. So we would have a purpose, we would have the data picture that I'm providing, and then you'll answer these 4 questions directly underneath that, and you will submit that under Newton's second law. PDF that one page. I don't need the whole lab notebook. I will check your whole lab notebook down the road. Please make sure it's up to date. But I want the one page. If the graph takes up a little more space, you push onto the second page, then both pages, but you should be able to get all this into one page. PDF that and submit it for me to evaluate this particular lab document. If you have any questions, please let your teacher know.